Okay, so as discussed in class, I'm going to go over this fast. Some are asking, what should we do in this and that in order to prepare. And I said all day long, um, I guess memorize or be familiar with these, three types of situations: circles, limacons, and rose curves. As far as what the equations look like, so that when you look at a question, you have an idea that that's what you're dealing with before you begin. Okay, and then that gives you a lot of, you know, a chance to really speed up what you're doing since you know what you're looking for, blah, 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 blah. So a little bit of memorization. I know that can be tough, but along with, the other things that you have to memorize for this section. But here we go. I'm going to go over this fast because I want to get this video done in less than 15 minutes and get it uploaded hopefully with no problems. Okay, so this one I recognize as our circle. I'm going to go ahead and do the what we have to do in order to get it in rectangular form. And then I'll tell you what your responsibility is, as I said, to fourth hour, a little bit more maybe, maybe both hours though. Don't worry about completing the square. I'll just accept this for right now. We'll do more when we get into chapter 9 in the Green Book, which I believe is next, about getting that in the proper format. Just realize that you have a circle and then go right to this, and this is how we're going to graph this fast. This is simple, and I'll make it simpler for you, not that it wasn't to begin with, a little scary beginning, right? What's sine of 0? Well, if you don't know that, that's scary. Sine of 0 is 0. And then, just do the quadrant. You know that this is supposed to be a circle, so that's half the battle. Once you know that, what's the sine of 90? And the answer to that is 1. But I'm going to go up. I want to see some sort of a picture, so I'm going to make that a label of 1. All right, and then I know that it's a circle. This is the highest and longest this value is going to be. There is no number in front of sine. So also knowing that, what's the farthest from the origin, the longest, position on the graph. And for this case, it's a circle, so that's the diameter. You could do some other values like, what's sine of, let's go 30. Sine of 30 is a half, 1, 2. So we know that point. And then sine of 30 in quadrant 2, is also a half. And then that gets you a little bit of shape of the circle here, and it does actually do that. So knowing that it's a circle, those couple points, hopefully, did I do that last one right? 1, 2, 3. No, I was off by 1. That's why I missed by that. So kind of hard to see sometimes the little intersections there. All right, already taken too long on that. So that's your responsibility. All right, knowing that this is a limacon, we don't have to convert this into rectangular. But so what kind is it? There's 3 kinds. There's ones that are cardioids that bounce. There's ones that are like flat and don't bounce and hit the origin. And there's ones that make that loop. We don't even have to have that memorized, whatever. This is what you're going to do. You're going to analyze a couple coordinates, like what's the farthest this could go from the origin? The answer to that's 5, because sine of something gets me -1, and -1 times -2 is 2, and 2 plus 3 is 5. That's the biggest number away from the origin. Where do I get that number? And the answer to that is when it's 270. Sine of 270 is -1, and then 1, 2, 3, 4, 5. That's the farthest point from the origin, and the only point that will be that far away. All right, then what's the sine of 0? The sine of 0 is 0. 0 times 2 is 2, or 0, sorry. 3 minus 0 is 3. So now we got another point, 1, 2, 3. Same thing happens at 180. So now we're starting to get a little bit of shape and we understand what's going on here. So what happens at 90? This is the difference with, limacons either being a cardioid or the one that doesn't touch or the one that loops. Sine of 90 is 1. So 1 times 2 is 2, 3 minus 2 is 1. So this never comes back down and hits or even goes through and does that loop. This is one of those where it's going to flatten out and then come down here and then just continue like this. So it's one of those limacons. Look at your 3 pictures of possibilities of limacons on that page that I shared with you. But don't just do this then, okay? There's more that you can do, and I'm going to do this with a lot of these. That was 1. Okay, I'm going to pick, what's best for sine, and it's 30 degrees. So I'm going to pick the 30 in quadrant 4. Sine of 30 is negative a half in quadrant 4. Negative a half times negative 2 is 1. 3 plus 1 is 4. 1, 2, 3, 4. Now you get that little shape, and the same thing happens with the 30 in quadrant 3. 1, 2, 3, 4. So then what happens is it loops out like this, then hits this point, loops out like this, and then it's one of those flatteners. Okay, so it almost looks like a circle. This actually, if you look at your graphing calculator, this is probably more flat than I'm making it right there. All right, so limacon in that situation. Good to go. Okay, this next one is a trick format. It's being mean. This is also a limacon when you write it like this. Which one is it? Well, let's go ahead and analyze that. There's rules, but just knowing that I'm going to have something like this, or a bouncer cardioid, or a hole, or a little loop-de-loop in the middle, weird one. So, first things first, as I like to say, we might want to go by, quarters, half, 1. So this is 1 right here. Just to see what kind of, because it's going to be kind of a small one. So play with your scale. Anyway, sine of 0 is 0. 0 plus a half is a half. Sine of 90 is 1.5, or sorry, 1, but then plus a half is 1.5. So this is 1, and this is 1.5. And then sine of 180 is the same thing, 0. So that's 0 comma half. And then this is where it gets weird. What's sine of 270? Sine of 270 is negative 1. Negative 1 plus a half ends up being here. So this graph is going to do this, and then it's not going to bounce in here. It's going to loop through here and then go around. And the reason that is there is a value that where sine is negative a half. And it's actually at this 30 in quadrant 3 again. Sine of 30 in quadrant 3, which is 210, I'm just trying to go over this fast, is negative a half. Negative a half plus half is 0. Then after this, that's when we start getting these values inside here. That's what Cooper's class, she really works on that. Where does it start going in there? Where do we get this interval? And it's these angles that this starts going inside of here. Because the sine of the 60 in quadrant 3 is negative root 3 over 2 plus a half is a negative. So it ends up flipping in here, going in the opposite direction. I don't really want to explain that any further. We should get a kind of a feel for what I'm talking about there. So let's get some shape over here. And the best way to do that is the 30. Because I just like the 30s for sine because it gives me a half and I can understand what's happening there. So sine of 30 is a half. Half plus a half is 1. 1, 2, 3, 1 represents 4 clicks for me, though. So, and then the other 30 in quadrant, make sure I put these, remember these go by 15 degrees. As someone pointed out in second period, I believe, figured that out. 1, 2, 3, 4. Same thing here because sine of the 30, which is 150 degrees, is also a half in quadrant 2. So when you put this all together, you have this, just smooth it out, get to there. This, maybe went a little weird there, but that's all right. And then we get these little values here, and then we get this loop-to-loop in here. And that comes from these values, basically after this 30 here, all the way up to the 30 in quadrant 4, where we get those reflected values inside and get that little loop-to-loop. Okay, so hopefully that helps you out. And this is the maximum amount of points we should be plugging in. Take a break for a second here. Already at 9 minutes. All right, never can do it. Mr. Blabbermouth here. 5 minus 5 cosine theta. Okay, that's a limacon. All right, so which one is it? We're going to get that little cardioid situation going on here? Well, let's find out. Cosine of theta. Cosine of 0 is 1. 1 times 5 is 5. 5 minus 5 is 0. Okay, so what's cosine of 90? Cosine of 90 is 0. So that gives me 5. 1, 2, 3, 4, 5. Okay, so we got that going on with us so far. Where is this going to be located as far as the big part of this graph? And it's really at 180. What I mean is cosine of 180 is negative 1. Negative 1 times negative 5 is 5. 5 plus 5 is 10. So it looks like we got a situation coming on like this, if you follow my pen. So I'm going to go back to here, My favorite value for cosine is 60, because cosine of 60 is a half. Half times 5 is 2.5. 5 minus 2.5 is 2.5. So now I see that this is what's happening here. You can kind of see that this is occurring. And then just to get shape over here, I don't want to go directly to that point. I'm going to get the 60 in quadrant 2. Cosine of 60 in quadrant 2 is negative a half. Times negative 5 is positive 2.5. So what I get for a value for that is 1, 2, 3, 4, 5, 6, 7.5. So all I'm doing is those basic values that we should already know from our basic trig values. So this is what I have so far. And you're going to get the same thing on this side. All right, smoothing it out when I graph these, because 1, 2, 3, the 60 in quadrant 3 is also negative a half when you take the cosine of it. So you get that 7, 1, 2, 3, 4, 5, 6, 7.55 value for that as well. And then 270 is 0 for cosine, so that's where you get 5. So it's all shaping out here, reflections of the way life used to be when Common Core did not exist. Cosine of 60 in quadrant 4, what just happened there? Negative a half times negative 5 is 1, 2, 3, 4, 5. What in the blazes am I doing? Cosine of 60 in quadrant 4 is positive a half. Half time. I said the word Common Core, and all of a sudden I can't do math. It's amazing. Half times 5 is 2.5. 5 minus 2.5 is 2.5. All right. I think I said what I wanted to there. So this is the cardioid, limacon. Okay? Now we're going to speed this bad boy up, or girl. This is 1 over cosine, multiply both sides by cosine. This is 5 cosine theta. This is the circle. Now what do we want to do for getting the equation of the circle? Just multiply both sides by r. And then this becomes r squared, which is x squared plus y squared. And then this becomes 5r cosine, which equals 5y. And then we'll work on turning that into the standard form of a circle next chapter. Blabbering. Okay, so how do I draw this then? Just take r equals 5 cosine theta. Don't draw this. Draw this. It's simple. What's the cosine of 0? The answer is 1. 1 times 5 is 5. 1, 2, 3, 4, 5. Now know that it's a circle. I can't help you on that. Cosine of 90 is 0. 0 times 5 is 0. There's the diameter of the circle. Okay, so if you know it's a circle, then we can have this happen. You can play around with some other values. What's the cosine of 180? Negative 1. So 180 comma negative 5 is this point again. So you're repeating. So you can get the circle created by doing these, but you really don't have to. The cosine of 60 is a half. So at 60, you would go, half times 5, 2.5. 1, 2.5. All right, so then when you draw this circle, that point gets hit. So really what I want is just those diameter values and know that it's a circle and it's over. Let's move on. Okay? Now danger, danger. Oh, I don't know this one. Okay? Well, I'll show you how this is, and we're actually going to graph this not using the rectangular parabola equation. We're going to go to this trig equation. But once I figure out that it's a parabola, then I could do this. Cross multiply. R plus R sine equals 2. R is x squared plus y squared. R sine is y. And then just determine that it is a parabola. X squared, a lot of room here, huh? X squared plus y squared equals 2 minus y. And then you square both sides. Freedom! Equals, I'm going to FOIL fast, 4 minus 4y plus y squared. I hope I didn't make a mistake. It's been a bad math week. Boom. It's a parabola that's going up or down. I told someone in 4th hour, if you want to know if it's supposed to go up or down, just solve for y and put it in standard form. We'll do the vertex stuff later. So what would I have to do? I'd have to subtract 4, so it's x squared minus 4, and then divide by negative a fourth, or multiply by a negative fourth. Okay, all I've determined is it should be a wide parabola that faces down because it's a y equals x squared. You don't have to do all that. Just determine it's a parabola. I might accept this answer, x squared equals 4 minus 4y. So just know that. So then go back. All right, I'm supposed to have a parabola, so how does that happen? Let's plug in some points. Plug in chug. Plug in a 0. Sine of 0 is 0. 0 plus 1 is 1. 2 over 1 when I get there. So there's 2. Guess what happens at 180? Sine of 180 is also 0. So you also get 2 for that value. See, isn't this nice now? Sine of 90 is, what's sine of, oh, I got scared. Sine of 90 is 1. 1 plus 1 is 2. I had to check that for a second. 2 over 2 is the common core in my brain again. All right, and then here, okay, so is this the parabola facing down? Darn tootin'. My pen stopped working. I love life. Mention common core, it screws up my computer. All right. All right, so this is in the way now, but 30 is the nice angle. 30 in quadrant 4. Let's just see what happens with that one now. What's sine of 30 in quadrant 4? It's negative a half. Negative a half plus 1 is a half. 2 over a half is 4. 1, 2, 3, 4. So now we're starting to get some coordinates that match this parabola. You know, and then the same thing happens for the 30 in quadrant 3. 1, 2, 3, 4. Is that what I said? Yeah. Did I go 4? I don't even know what I'm doing. 1, 2, 3. I went 5. You know, counting is a skill, isn't it? Jeez. Common core. 1, 2, 3. I still can't count. Good thing this is on YouTube. Go driving myself nuts here. But I survived today. Didn't get fired. That's good. I hope I did that right. I feel nervous that I missed a point, but looks good. So that's how you get that parabolic. You go to this equation, not that one. It's actually not as bad as we made it. We being me, my many personalities. Okay, so now, what's this? Well, you better know it's a rose. And then you better know it's a rose with 3 petals. And the highest value is 2 away from the origin. So really what you got to do is find out where the end of the petals are and then make a sketch. And I think you're going to be good to go. So, now I'm so nervous I got to get the kids after school today, so I might not be able to post this video right away. Nobody cares. Cosine is 0. 0 times 3 is 0. So cosine of 0 is 1. 1 times 2 is 2. Guess what? You got one of your petal ends. True story. That's going to be one of the rose petal ends because that's the highest value away from the origin you're going to be with that 2 times. You know, cosine of any angle measure can only be 1 or negative 1 as the highest and lowest values. That's why I know that. So then now the next thing is 3 times what equals 180? Because the cosine of 180 is negative 1. The answer to that is 60. So let's see what happens when I do that. Ooh, squeaky. So 3 times 60 is 180. The cosine of 180 is negative 1. Negative 1 times 2 is negative 2. So I have to go 1, 2, but I must go in the opposite direction. There's end of petal number 2. Isn't this crazy? All right. Then where's the next one that lands at, let's say, like 360? So 3 times what is 360? And the answer to that is 120. 3 times 120 is 360. The cosine of 360 is back to 1. 1 times 2 is 2. So when I plugged in 120, I got cosine of 360, which gave me that. And then, I'm really, someone's probably going to be mad at me as a teacher, like trying to show you this real fast and easy, but that's where your rose petals come from, and then you can verify all the other, rose petals, going from there. But that's it. I don't know. I don't have time to go into that any further. I really think that's the best thing you can do on this. Know how many petals you're supposed to have, and then find the angle measures that get the end of the petals. Let's move on. This is r equals 3. It's a circle. Let's move on. Oh, it's a circle because r is square root of x squared plus y squared equals 3. And it's a circle, x squared plus y squared equals 9 when you square root both sides with a radius of 3. Okay, fine. And then this is a rose with 4 petals. Whenever the even number is there, 4 petals get created. The farthest away you're going to be from the origin is 4. Where does that happen? Well, it happens when, I'd like to take the sine of 90 because that's 1, and then 1 times 4 is 4. Right, I just wanted to make sure I said that. So 2 times what equals 90? 45, wow. I literally did not know that answer when I was thinking about that. So here's 45. So when I plug in 45, 2 times 45 is 90. Sine times 90 is 1. 1 times 4 is 4. There's end of rows number 1. By the way, when you plug in sine of 0, you get 0 times 4. Right? And then where's the next one? Like 270. 2 times what is 270? And the answer to that is 135. 2 times 135 is 270. Sine of 270 is negative 1. Negative 1 times 4. This is what happens, though. I get 4, but it's a negative 4, so this bad boy or girl flashes across the other side. There's end of pedal number 2. And I bet you know where the rest of the pedals land. But anyway, so what's the next nice number that I want? It's probably 225, because you know what 225 times 2 is? It's 450, which is 360 plus 90. So sine of 450 is back to 1. 1 times 4 is 4. So definitely fast tracking this, but it's based off of knowledge. Did I do 4? Okay, knowledge of knowing that this is a rose. Where are my petals? Let's get this over with. All right, and then what's the last one? Well, 315, this pattern is that the 45s represent these chunks of where the rose ends up. 2 times 315 is 630, which ends up being 270. Sine of 270 when you get the 360 out is back to that negative 1 value. Negative 1 times 4 is negative 4, which means you have to go in the opposite direction. And then there are your petals. You can get better drawings by, and I'm kind of doing a bad job with this, but you could go further. But, for time, and you know how tests work, it's the general ideas that you have to get after, doing the long, hard work that we've had in the past. Okay, 3 more, and I might quit, and just show you the key on this because I want to get this movie going. Do the best you can. This is kind of tough. This 21, so hopefully you can get that. 22 shouldn't be too bad. Now that I've taught you how to graph these, it shouldn't be too bad to find out what these equations are. So check yourself through my key that you did the right thing on those. All right, so let's go back to this one. All right, so 4 over sine theta. Okay, remember what we said on this. Give me a second here. I don't know what this one is, but if I multiply by r sine theta both sides, then I see that this is y equals 4. All right, so I think this one, you do need to get this into a linear rectangular format so that you know that this is a horizontal line. So multiply both sides by sine, replace it, you get y equals 4. It's all over. Then this one, this is going to be another memorize situation. This is the classic line scenario where this is c over a cosine b sine. And it mirrors ax plus by equals c. Probably another thing you're going to have to memorize. Sorry for my c looking so bad there. So it's 1x minus 3y equals 2 is what this mirrors. Okay, and then what we're going to do on this one is superimpose a rectangular coordinate plane on this using the same units, 1, 2, 3, 4, and it will work out for what, you could check on your calculator. Am I doing the right thing or not? Not on the test, but, when you're double checking your work, is this right? And it is. When you solve for y, you get y equals 1/3 x minus 2/3. All right, and then that means you have a y-intercept of negative 2/3, which is right around here, and then rise 1, which is right around here, run 3, and you're approximately somewhere right here. And 2 points make a line, be done with it. Then when you put your calculator in polar coordinate form, which it already is, and then type this in for r equals, you'll get this picture smack dab right on, spot on, as they say. And then this one is 2 cosine theta, which is just a circle. Okay, so if you recognize this as a circle, multiply both sides by r, and then this becomes 2x, and this is x squared plus y squared. You get a circle. Well, then where is it? Well, plug in some points. And I know it's a circle now. Cosine of 0 is 1. 1 times 2 is 2. Okay? Cosine of 90 is 0. All right, there's your diameter. There's your circle. Isn't it cute? Okay? All right. I'm done. I'm composing the video. Check your work for reverse analysis on how we get these answers, and hopefully it works out for you. I don't even know what I'm hitting.